Welcome to Stage 02, where we get serious about services on Ubuntu. Lesson 06 is the foundation for everything that follows, because system runs every service on the box, from Nginx and SSH to whatever custom app you ship. Master the unit file format, and you can deploy any service, set restart policies, wire into the journal, cap resources with C groups, and debug why won't this thing start in minutes. Over the next slides, we'll walk the anatomy, the 6 unit types, the 5 type DORIS variants, and the dependency model that decides startup order. Before we touch a single config line, grasp the big idea. System replaces 3 legacy tools, sysvinit for daemons, cron for schedules, and mount with fstab for file systems, by collapsing them into one abstraction called a unit. Services, timers, mounts, sockets, targets, even path watchers all share the same file format, the same system call commands, and the same journal. 3 locations matter, journalctl for your overrides and custom units, run for transient runtime state, and lib for whatever apt installs. And never edit that last one directly. Either copy the package unit into etc. or drop a small override .conf with just the keys you're changing. Now that you know everything is a unit, let's dissect one. Every service file has 3 sections, and they map to 3 questions. The unit block answers, what is this and what does it depend on? Note wants for soft dependencies versus requires for hard ones, and after for ordering. The service block answers, how do I run it? The type, the user, never root unless you truly must. The exec start command, restart policy, and C group limits. The install block answers when to start it on boot. That wanted by line is what systemctl enable actually wires up. Copy this template. Every line here earns its place. Dependencies trip up more engineers than any other part of system. So let's untangle them. There are really 2 separate questions. Ordering, who starts first, handled by after and before, and relationship, what happens if the dependency fails, handled by wants, requires, and bins to. Wants is your soft default. It tries to pull in the dependency, but tolerates failure. Requires refuses to start without it. Binds to goes further and dies when the dependency dies. And remember the golden rule at the bottom. Wants without after means parallel startup, which is almost never what you want. Always pair them. Now, once dependencies are sorted, system needs to know when your service is actually ready, and that's what type controls. Get it wrong and system marks the service active before it really is, which means dependent units start too early and restarts behave unpredictably. Type turns simple is the default and the right pick for modern foreground apps. Use forking only for legacy daemons that background themselves, one shot for setup scripts that run and exit, and notify when your app can explicitly signal readiness via STD or notify. That's the gold standard for things like PostgreSQL. When in doubt, stay with simple. So you've got type words dialed in. But what happens when Nginx ships a unit file and you need to tweak it? Don't copy it into Gakra etc. and edit there, because the next apt upgrade silently wipes your changes. The right move is a drop-in, a tiny file under etc. system Nginx service.d that holds only your overrides, and system merges it with the vendor unit at runtime. The easy path is sudo system edit Nginx. It opens an empty override. Conf, you drop in just a service block with restart mash always or memory max 04g, save and system reloads for you. Use systemctl cat to see the merged result, and systemctl revert to wipe your changes back to package defaults. Now that you can safely override units, let's talk about the single most important override you'll ever write. The restart policy. The default is restart during no, which in production is a disaster. One seg fault and your service is dead until a human notices. Set restart and failure with restart sec 5s, and system brings it back in 5 seconds on any non-zero exit or signal. Then pair it with start limit burst of 5 and start limit interval sec 300. That says after 5 restarts in 5 minutes, give up and mark the unit failed, so you don't thrash on a permanently broken binary. Once you fix the bug, System's heal reset failed clears the counter and you're back in business. A restart loop is great, but what if the bug is a memory leak that eats every gig of RAM before crashing? That's where C group limits come in. Because System already drops every service into its own C group, you get resource control for free. Just declare it. Memory Max 2G gives you a hard ceiling that kills inside the C group instead of taking down the host. Tasks Max 512 stops a fork bomb cold, and CPU quota shucked at 50% caps the service at half a core. Verify with systemctl show and watch live usage with systemd cg top. On any production service, Memory Max and Task Max are cheap insurance you should never skip. Once your service is running and bounded, the next question is always, what is it actually saying? Because System captures every service's stout and stir into the journal automatically, you get structured, indexed logs for free, no log4j config, no log-rotate cron. The three flags that cover 80% of your debugging are U to scope to a unit, F to follow live, and since for a time window. Layer on P air to cut info noise, or B1 to jump into the previous boot when something died before you could catch it, and when disk fills up, vacuum size and vacuum time trim the journal in place. Logs in hand, let's talk about the 5 gotchas that will bite you in production. Number 1 is the classic. Once brochures without after, or once declares the relationship, after declares the ordering. Hod drop after and both units race in parallel, which is why your app sometimes hits Postgres before it's listening. 2. Edit a unit by hand and forget daemon reload, and systemctl restart will happily reload the old config. 3. Type simple on a binary that forks. System marks it active the instant exec returns, even though the real daemon already exited. 4. Memory max silently, killing inside the C group while the host looks fine. And 5. Stop hangs for 90 seconds because your app ignores sigterm and timeout stop sec hasn't been tuned down. Memorize these. They cover most of the tickets you'll ever file against Systemd. With those traps in your back pocket, here's what you actually walked away with from Lesson 6. 6 concrete skills. You can dissect a unit into its 3 sections, recognize all 6 unit types and where they live, wire dependencies with both ordering and relationship directives, pick the right type for how your process behaves, set restart and resource policies that survive real load, and finally extend, inspect, and account for any unit with drop-ins, journalctl, and C groups. That's system fluency, and it's the prerequisite for Lesson 7, where we put nginx out front with modern TLS, Let's Encrypt, and an A+ on SSL Labs. And that's Lesson 6 in the bag. Systemd mastered. Unit anatomy, dependencies, type and restart policies, drop-ins and C groups, all checked off. Next up in Lesson 7, we put that foundation to work. nginx as a reverse proxy. Let's Encrypt automated through a system timer. TLS 1.3 with modern ciphers, and the security headers that earn you an A+ on SSL Labs. When you're ready, run next lesson. Start, and I'll see you there.